In this tutorial, we will discuss an example of multiple regression using SPSS. We will be using the simultaneous regression method. Multiple regression is a statistical procedure for determining which of a set of variables significantly predict an outcome. Note that in this example, all of the variables are continuous, meaning at least interval level, or else dichotomous, meaning a nominal variable with just two categories, such as gender. We will not be using nominal variables with more than two categories, as such analyses are beyond the scope of this tutorial. To begin, let's select an outcome variable. We want to know what variables predict a reading achievement test score, labeled as read ACH. Now we'll select some predictors. Let's hypothesize that gender, number of hours of TV per week, and number of books read prior to intervention all predict reading achievement. Note that it is important to avoid causal language with regression, as whatever results we obtain are correlational in nature. Go to the Analyze menu and select Regression, then Linear. In the box labeled Dependent, enter Read ACH. Again, note that SPSS uses the terms dependent and independent, even though the analysis is correlational. Preferred terms are outcome for dependent variable and predictor for independent variable. In the box labeled Independent, enter gender, TV hours, and books pre. Then click OK. The box labeled Model Summary provides the R statistic, which is the multiple correlation coefficient. This statistic tells us how strongly the group of predictors is related to the outcome. In this case, R equals 0.86, rounding up. To determine how much of the variance in reading achievement test score is accounted for by the predictors, look at R square, a whopping 0.73 or 73%. Next, we examine the F test in the box labeled ANOVA, which is a significance test determining whether R is significantly greater than 0. In this case, F with 3 and 36 degrees of freedom equals 32.54, and P is less than 0.001. This means that the group of predictors is significantly related to the outcome variable. However, it doesn't tell us whether each of the predictors is a significant predictor. To determine this, we must look at the next box, labeled Coefficients. This box provides the unstandardized coefficient for each variable, labeled B, and a measure of standard error for each coefficient. The standardized coefficients are more easily interpreted. They give the relative weight of each predictor variable in terms of predicting the outcome. Larger beta weights are stronger predictors. The results of a t-test of each predictor are also provided, with the t-value and the p-value. As you can see, gender and number of hours of TV are not significant predictors. P's are greater than 0.05. However, number of books read was highly significant, P less than 0.001. Note that SPSS does not provide degrees of freedom for the t-tests. To determine degrees of freedom, take the number of participants, n equals 40, and then subtract the number of predictors, 3, and then subtract 1. The degrees of freedom for each t-test of the beta weights is 36. Thus, if we were going to predict reading achievement score for a student in this sample, we wouldn't need to take gender and TV watching into account. We just need to know the number of books that a student read prior to the intervention, and we could fairly accurately predict the student's achievement score. Indeed, if we reran the analysis with books pre as the only predictor, the multiple correlation coefficient hardly decreases at all. In summary, multiple regression can assist in cutting down the number of variables used to make predictions to just those that are significant. But be sure to remember, correlation is not causation. We cannot conclude from these data that reading more books cause students to have higher reading scores, just that these two variables are associated. This concludes the tutorial.